Well, good afternoon, everybody. Thanks for logging in. I have 1 o'clock here in the East Coast. So thanks for joining us. I know how busy everyone is, and to take some time out of your busy days, really appreciate the time and the attention. What we have today is to kind of give a broad overview of what you might be facing as you are going through the process of maturing or developing a kind of a scanning tool set in a survey and engineering discipline, going from kind of that first drone into something a little bit larger, or maybe you don't even know what a drone is still. You could be flying an old Phantom 4 RTK manually and trying to stitch things back together. So this is in no means to be a compendium, kind of end all be all. We wanted to provide some guidance as to what we might be looking at as you're just getting into this in the Northeast. So thank you very much for coming, and we hope you get some value out of this. So I'm Tom Searing. I have come from, I was a former channel rep for Wingtra in the geospatial industry. The last 2 years, I have been flying drones and crunching data all over the country. It has been my privilege to be able to, use some of the most cutting edge tools as a rep for Seiler, to be able to get out in the field, meet so many of you fine folks, and so many cool projects that you guys have done. It's truly amazing. I love what I do. My colleague here joining me today, Harry.
Yes, thanks everyone. So I'm with Waypoint Technology Group. I'm a licensed land surveyor and one of 2 remote pilots here. And I've been using Trimble hardware and software since the late 90s, so very well versed in Trimble technology. The drones are somewhat new to me, so it's great to have Tom here to kind of complement my expertise. Through Seiler Geodrones, we're able to offer all of the different exciting technology that we're talking about here today. So it would be great to get started.
Yes. All right. So what we're hoping to achieve today, we'll be talking about, high-level photogrammetry and LiDAR fundamentals, the application of air and ground-based scanning, hardware and software landscape, kind of giving you an overview of some of the technology that you have accessible to you. We're going to talk about a test data analysis that we did at Harry's lovely ranch. Accuracy considerations, ground control, and checkpoints. We're going to discuss these and show some reasons to kind of be very diligent about this. We're going to talk about budgeting considerations, not just for the projects, but also the hardware and the software as well. Deliverables and processing, workflow process review. As you can see, there's a lot to get through, so we're going to get right into it.
Yeah, today is just, part of a series that we'd like to offer to everyone. We'll do another webinar in the fall that's more geared towards specialized applications like inspections, how to get the most accuracy out of the sensors that you're using, and some other types of sensors that, Tom's going to kind of allude to later on. But today is more of the basic UAS technology introduction.
Excellent. So what are we doing with this? All right. I mean, I think a lot of us know, but for kind of a basic, baseline understanding, what are we using geospatial data for out here? Certainly site selection and analysis. Typically that has been used in years past with satellite and aerial photos, right? Doing this from Cessna 172. We're doing infrastructure asset management, monitoring all phases of construction, and from site selection, green fields, all the way back up to occupancy and turning it over to the building owner. And then what do you do? I mean, even if you're getting into BIM and building information modeling downstream of this, there are all kinds of reasons to be gathering this data and all kinds of things to be monetized and deliverables to be created for your customers. Environmental impact assessment. I mean, this list is growing. This is a good baseline, but certainly where the future is exciting. here we are in the Northeast, some unique challenges here that we have to deal with. Intermittent cores networks, scanning issues, hardware issues, drone problems, as far as controlled airspace. I mean, all kinds of problems, challenges unique to the Northeast here. So how do we navigate all of this, right? Got critical infrastructure that needs to be monitored as built. But what are some of the problems that we have, right? We got bad weather, right? I get asked about this a lot. People ask what the IP54 rating is, or what's the, the waterproof rating on certain drones. That's great if they have that capability, but again, what kind of data are you getting in bad weather? We have population decreasing, right? So this is another challenge. We have the high cost of living in the Northeast. We do have older infrastructure. Any of you folks are working out in, any of the historical preservation societies of any of the number of cities, those permitting and regulations for that are very, very cumbersome working through that. Employee retention and labor shortages. These are all real problems that we have to figure out a way to work through. The rapidly changing landscape of technology. It is a full-time job keeping on top of what these OEMs are doing on a daily basis. One of the things that we do for you is to stay abreast of these changing technologies so we can provide good tool sets for you. Last but not least, we have foliage, our eternal nemesis, right? Being able to get good geospatial data through these trees and the random bushes and what have you out here in the field. So
the most common challenge I'm seeing as I'm talking to our different customers is trying to do more with less. Everyone's having a hard time finding manpower. UAS could be a very good technology to try to solve that. You're doing a lot more faster, easier, and safer than we've been able to do in the past.
Definitely. So talking about terrestrial scanning versus aerial scanning, Harry, why don't you take up the terrestrial side here, the land-based, my friend?
Yeah, so we don't always have the opportunity to use both types. It just depends what tools you have in the toolbox. But if you do get to choose between the two, there's a lot of different considerations you might have. Is anything, if it's over a few acres, it might be worth using a UAS system. But how accurate does it need to be? How much detail do you need to have? These are all some of the different things that we need to consider. How accessible is the site? So that may prove to be in the favor of one technology over the other.
Absolutely. And on the other side of that, right? Wide coverage, right? So if you're in the air, you can certainly capture a large data set very easily, right? That's one of the best things about this. Obviously we got the Wingtra up here. It's excellent at doing that, just that wide scale mapping. So roughly 800 acres in a rip. I mean, so that's undeniable. To create good ortho views, right? Can you create good ortho mosaics from the air? Yes, certainly we can. We've been doing it for quite a while, going back into World War I and reconnaissance. So it's not anything new, but the scaling of this technology and being able to have it in your hand and to leverage the power of that to create things like 3D models, digital terrain models, digital elevation models, and access these hard to reach locations someplace, for instance, might be bad to go to send someone, a very dangerous, high wall in a mining operation. It could be a slag or talus dam, where you might want to monitor that. It would not necessarily be a great place to send person. I just recently heard about a near miss at a landfill operation. Someone was up doing check shots on a giant garbage pile, for void. A void actually collapsed and it was a rather dangerous situation. So places that you don't want to send human personnel into, we have these robots to leverage. It's excellent. Again, why use them, right? Like I was just talking about, safety, right? And again, we can easily collect this data in hard to reach or dangerous places. Now, is it improved over traditional inspection, right? Being able to leverage from the air as opposed to being able to scan it up close in the ground. If you can get to it, potentially, we're going to talk about that a little later. Time and cost savings really are kind of undeniable. You know, we do have some slides on this later, be able to show what a crew, like an actual land-based crew versus a drone, even, you know, a smaller drone like a Mavic 3, like is shown here. It's really, there's no contest. You know, we're talking about John Henry and the steam shovel here. So allowing for certain views, again, that were impossible essentially to get to, right? Being able to have the microtization of that aerial photograph in your pocket, essentially, from, you know, behind the seat in a Mavic 3 is truly revolutionary. And we're increasing the data quality, right? As this is happening, we are being able to get better data from the field, and with that, the software on the back end that we are able to consume the data into some very exciting things, software programs and machine learning tools that are in development for what we'll be able to do with this data downstream in the years to come is also a very exciting place to study and spend time in. That being said, we do have some federal regulations that we have to look up. With 108, we were supposed to have 108 regulations at the end of 2020. So I would love to see what we're looking at. I think that's definitely something that's long overdue. Hopefully we'll see 108 coming out here in the very near future. So before we get into a project, there's some budgeting considerations we have to look at. How large is this project? How large are your typical projects? How often do you have to fly them, right? Are you doing it once a day, once a quarter, or do you have to fly multiple sites, multiple days a week? Thinking about these things, going into what kind of gear you're looking for is extremely important. What's your necessary ground sampling distance, your GSD? This is something we're going to talk about a little bit today. You know, understanding what your requirements are. Just because a LiDAR sensor can get, you know, 1,000 points per meter, does that mean you really need that in your point cloud density? I don't know. It's an interesting question. I would definitely love to hear from the audience, you know, once we get into this section. What are the burden rates? What's a realistic burden rate? You know, you'd be able to factor this in when you're, you know, doing bids or trying to win projects first, being able to get out and use data from a drone to make more accurate bids to win more business. These are definitely things to think about. So as far as the actual hardware is concerned, now taking, you know, the capability in the previous slide, now we're talking about the actual drone itself. What is it, you know, going from an application to the actual the hardware capability itself? Is it RTK or is it PPK, right? You have real-time or post-processing kinematics, and understanding, you know, what those two are, real-time versus post-processing. Essentially, do you have an RTK that's giving you real-time update on your position, like nice cores or mass cores, or are you doing post-processing kinematics where you're taking like a TO2 or a TO4 file and converting it to a RINEX with the right sampling rates, and, you know, getting the right version of RINEX. These are all things to be considering. Is this now NDAA compliant? This is another potential pitfall, right? Is your drone good to go? I mean, if you're doing state projects, you're doing federal projects, these are considerations to think about. If you're able to actually use the drone that you have, with what's going on with the, you know, the covered list and the, you know, the China ban, we'll call it here. Photogrammetry and LiDAR, right? What type of sensor package do you need? Either or, both. Again, all subject to the you know, what your project consideration is. And then if you get into, once you have this, you've got this great new tool, how can you then leverage it downstream to make, you know, increase your business or do something that maybe you're not doing right now that you could be doing with the technology to monetize it for your business downstream, you know, through an alternative sensor like a bathymetric, you know, again, going back to that, you know, that mining operation, again, going in and being able to do bathymetric analysis on, you know, someplace that didn't have any terrain data at all to speak of, and as you excavated down through a mine, right? This is an area where you'd be able to use drones, or methane for landfills, doing methane heat maps. That's another hot button that I've been talking about a lot recently, doing methane heat mapping and thermal assessments. Maybe you're doing operation and maintenance inspections on solar fields, or generators, or critical infrastructure. So there's all kinds of things to think about.
Yep. On that first bullet point there, I'd be remiss not to mention that our new R980 receiver is a good fit with the drone, because it takes a 4G SIM card, so we're able to actually dial right into a portable base station through an N-trip connection, or you can set that same receiver up to do your PPK. So it's definitely, I'm finding, a very nice complement to your drone package there.
Absolutely, love that. So getting into the kind of the granular fixed wing versus multi-rotor, right? So there's a couple of different, I guess, main flight characteristic decisions to look at. Kind of thinking about what we talked about earlier on. How large of a site are you dealing with? What's a typical site for you? Is it something that's going to lend itself to a multi-copter or a fixed wing, right? So the pros of the multi-rotor, they're typically a little bit more robust in the wind. Check this list here out. Obviously, they're the taking off from a small space, right? Thinking about this M30T that's here, or any other quad, it could be an M3E or an M4, the new Matrice 4 that DJI just released. The point is that it's easily deployable. You can get one out of your truck. For instance, the M3, I could have that out of my truck, out of the box, and up in the air as fast as I have cellular and RTK connection, which sometimes could be an issue, which may be a reason you want to use PPK. That being said, the battery life and slower overall data capture, as far as the footprint and what it can capture in one mission, you're going to be limited there. Regardless of what they're doing now, they are trying to stretch the legs and get that endurance higher. But again, fixed wing is designed for maximum endurance, right? So you're definitely going to see longer flight times, longer endurance in a fixed wing. But that's going to come with some limitations, right? You're going to give up, being able to have that first person view, that actual live link to the drone in some cases, right? I'm thinking about something like the Wingtra, for our purposes today, talking about survey and mapping folks. Not necessarily like ISR birds, like for those of you might. So that's intelligence gathering, surveillance, and reconnaissance drones. So some of the mapping drones can be dual function. I'm thinking about like a quantum system drone, right? They actually do have a sensor that you can see real time links to it, and it is a fixed wing vertical takeoff drone as well. But again, you are going to see the budget is going to go up significantly once you cross over into those maximum endurance. Census is another one that falls into this category, but they're excellent at what they do as far as over the horizon and being able to do that beyond visual line of sight. So all of these are factored in when you're thinking about what is the hardware, what is the actual drone flight characteristics, and what is the data considerations that you're looking at going into a project. So what I want to talk about here, just a couple of quick slides to go through some of the drones that we're working with currently that we have in the stable that we're going to be showcasing today. Some of the data that Harry's got to present here from our project was from the Whisper Sky Scout. So I'm going to talk about a couple of manufacturers that you probably have heard of, hopefully, and we have on hand to show you and set up demonstrations as we get into the flying season here this spring. So the Whisper Sky Scout, again, it's an NDAA compliant. I'm going to say that again a couple of times, NDAA, the National Defense Authorization Act. So this is something that you could take out and fly in maybe not necessarily military base, but certainly it is not on the covered list like a DJI or an Autel. So that is excellent to know right up front, right? It is about a 30-minute flight time of the payload. It's again very compact, very portable. It's very easily deployable. I've come to really like the Whisper Sky Scout. It's got an excellent assortment of payloads, some thermal options there. GeoQ has just released the new TrueView 1 and the TrueView 1 Lite, which are amazing LiDAR packages. It very reasonable cost for as far as like, you know, $18,000, $19,000 for a LiDAR sensor is pretty remarkable for something that is not DJI branded. So the fact that you could throw that on a Whisper, have a, you know, a colorized point cloud with a drone for under 30K, that's pretty awesome. Ranger Pro, if you need something a little bit bigger, you want to be able to carry, you know, something like a methane detector, like a bathymetric measurement tool, you're going to need something bigger, right? So you get into something like a Ranger Pro, having to have that 7-pound payload. This thing is a beast, right? So if you do need to get into some of that more niche payload, this might be an option for you. It's also really great if you want to, I would say, like, hack it. So for those of you that might be in research institutions, if there are any of you on, the Whisper is like the mad scientist laboratory drone. It's very hackable in the best way possible, not like in a bad way, but in a way that you wanted to change sensors and integrate sensors. You can do that very easily with the Ranger Pro. And I would love to talk to you about that in a deeper dive. Wingtra, my old alma mater there. Great. The Wingtra 1 Gen 2 is an amazing bird. It's super reliable. Like I said earlier, talking about Wingtra's really going in on the end-to-end solution. So they've just recently at GeoWeek a little while ago released their cloud and their ground platform together. This is an entire tech stack inside. Everything from the GNSS head to the processing of the software happens inside all of the Wingtra technology. So it is the easy button. Everything talks to everything else. It's fully automated inside the actual application. They've done this very, very well. So again, just as far as ease of use and reliability and deployment, I really like what Wingtra is doing right now. And being able to share your deliverables and process your deliverables without some kind of intermediary. All of these OEMs are going to cloud-based. If you haven't seen that yet, it's just there, right? The cloud it's very necessary evil, right? It's going to be there. It's something that these companies are going to continue to do and put more resources into their cloud-based applications. So if you're those that don't like the cloud or don't like SaaS-based software, I completely feel you. I understand having that perpetual license of something and not having that SaaS to outlay every single year. I totally understand where that's coming from. Unfortunately, the market is going someplace else, you know, and trying to stay abreast of that. Inspired flight. So the IF 800 and 1200. So the Tomcat, again, NDAA compliant. This is another one. 43-minute flight time with pay. Again, these are rough estimates based on the payload and certainly wind conditions and, you know, your conditions on the site. But the IF 800 it's a very robustly well-designed drone. It's rock solid. Taking it out, looking at it, it looks very similar to the DJI M350. And I think that was not an accident, you know, as far as the form factor and the design of it, you know, wanting it to be familiar to something that a lot of us are using or have used. Payload capacity, 2.5 pounds on the IF 800 as opposed to 19 on the 1200. And these two systems, I think Inspired Flight, one of the things I love about Inspired Flight is the integration of the myriad of sensors that are on the market right now. IF does this exceptionally well. So for those of you that want to integrate an existing sensor that maybe you already have, maybe you're in a more mature drone environment and you have a more mature drone program, and you want to get another bird, or you need to get one, or you want to grow that program, and you already have a sensor that you want to repurpose and have on your new system, right, to be able to cross-load these things. IF does this very, very well. And again, this is something that we can help you with. Sensor integration, was just talking about this, right? Being able to take all of these different sensors and get them onto the bird. This is a huge kind of I would say, pain, right? being able to get something off the rack and get it to talk to your bird through different hardware, different software interfaces. When I was just referring to the wing chart, talking about that tech stack, right? Something that lives inside and talks across all of the platform and software, it's a challenge. So being able to do this and change these and recalibrate them after you've taken it off of something and put it in a different mount, for instance, these are really challenging areas for certainly for novice folks to get into, which is why you don't have to go it alone. Leverage our expertise. We routinely do this, and we can help you work with whatever OEM you're working with and get the right sensor for you on the bird. So stepping into our software overview here, there are many different processing software out there, right? So UAS Master, TBC, DJI Terra, Wingtra, LP360, Pix4D, AutoCAD. So there's so many of these out there. And this is really focused on processing, not even necessarily fleet management, which could be a separate slide and a separate presentation going into management for something like a, like a UGCS or something like that. But this is definitely something that we really want to drill down on today. Harry is going to be talking about TBC and UAS Master where you process the workflows. Many of you through Waypoint, I expect, are probably TBC users as well. So Harry, did you have any thoughts on this?
Yeah, so as I bring myself up to speed on especially the back end of this workflow, I've been, a Trimble purist, so I'm using TBC and the utility that comes along with that made by Info, which is UAS Master. And just from my own experience and what I'm gathering from other users, comparing it to Pix4D, as far as ease of use, you'll have TBC, Pix4D in the middle, then maybe UAS Master at the high end. What I'm finding is if everything was done properly in the field and there's really no issues, you can process it very quickly and easily in TBC. But the moment that you don't get the results that you want, there's not a lot that you can really do there. But that's nice because we have UAS Master that comes along with the photogrammetry module as well. And that will take any imagery, whether it's from the air or the ground, and give you something. And there's so many different controls in there that I've been able to process many data sets that TBC kind of refuted or aired out on the UAS Master will give you something. So yeah, between those two modules there, very complete suite of software tools.
All right, so photogrammetry. I'd say most of you are probably pretty familiar with this in the event that you're not. But what we're wanting to focus in on here is some of the considerations with photogrammetry, right? So this is pretty ideal for hardscapes, right? Areas without much vegetation, right? We're going to talk about that with LiDAR. It's great to make 3D models or digital twins with photogrammetry. You just have the resolution. You don't have that with LiDAR unless you're talking about something that's got, an onboard RGB sensor as well, and we certainly have plenty of those to talk about. But straight photogrammetry, like you see the Sony platform here on the left, or the DJI P1, those are typically what you're going to see for just straight photogrammetry missions. And again, I'm flying typically 80% side laps for my photo missions, depending on the homogeneity of the scene, right? So if I do have a lot of, if there's like a desert or something, or the fall field, something where you've got a lot of non-discernible, again, homogeneous scenes where you've got color palettes are similar. This is going to be an area where you're going to want to definitely increase your amount of checkpoints and ground control as represented here. Again, propeller, got some very cool tools out here, automatic GP ground controls, and your typical run-of-the-mill ground control here as represented here. Going into LiDAR, if any of you know what that is, congrats to you, the old STI. So this is what we're talking about. Again, if you happen to not know what's going on with LiDAR, this is a representation of, your standard fixed wing plane with a LiDAR swath. What we'd be seeing typically. Now we're seeing this represented on a drone, and you could actually make out there's a little quad underneath the larger, airplane in that representation. So what we have done is essentially taken that and microtized it here. So LiDAR is essentially beaming, millions of points, per second down there, and not necessarily shooting. I've heard this said before. You're shooting through the vegetation. In a sense, you're essentially shooting around the vegetation. You're pulsing through, spaces in that. And again, from photogrammetry, I would say you're typically going to see your resolution drop off. We talked about that. I mean, depending on your characteristics, but I'm talking, sub-centimeter in photogrammetry GSD, where you're not typically going to see that with a LiDAR scan. So, but it does allow you to map point clouds for, again, complex infrastructure, transmission towers. If you've ever seen a substation LiDAR set, it's great. And for vegetation encroachment, not necessarily. If you're not doing monitoring of transmission lines, or if that's something you have to do periodically, it's excellent for that as well. So some best practices to talk about for photogrammetry, again, 10 o'clock to 2, right? Basically talking about shadows here, right? We want to make sure that there is, no rain, snow, extended water, overlaps, 80F, 70F. So this is 70 side lap, 80 front lap. And that's going to change depending on what your bird is. But these are some good out of the box, I'd say, default settings. Your ground control and your check shots, these are going to be necessary. Non-reflective, heterogeneous, simple geometry, right? So that would be, your wide open field, or, an urban parking lot, or, a shopping center, things like that are going to be excellent for that. Getting good curb lines, even with photogrammetry, depending on your side lap and your front lap and what you're doing in your mission planning. Now, you do want to be sensitive to winds, right? Calibration errors, zebra striping, all kinds of different artifacts from bad planning. Into LiDAR, talking about point cloud density, I mentioned this earlier. What's good enough? How many points per meter do you need in or in a data set? This is something I would love to have during our Q&A at the end, to actually kind of pull some of the folks on the call here. Your IMU calibrations, remember to do this. Not all of them are automated. Not all of the birds will do this automatically for you. So being sure that you're doing this and you're calibrating your IMU, this is very important. Typically performing at fast speeds, right? Meaning not super fast. This typically between 10 and 12 miles an hour is what we would say, fast, right? Too fast, you're going to outrun the IMU. If you go too slow on straight long lines, you'll wind up losing the IMU. It actually kind of gets drifted over, really long straight lines. So this is also stuff to consider when you're getting out into the weeds here. And again, sky high targets, right? Just because you're using LiDAR does not mean that you don't need ground control, right? They make LiDAR high reflective LiDAR targets, which we've deployed for Harry's targets in the project we're talking about here. Water is not good for photogrammetry or LiDAR, right? That's kind of ubiquitous. In case you didn't know about the returns, right? You hear people talking about LiDAR returns. Touting the different point cloud, density, capabilities, accuracy, all of that, right? This is what's happening, right? So some of the sensors on the market have, multiple scans. Some are, single scans, some are 3 scans, some are 5 scan. So what all of that means to you is essentially how many different shots are you taking at a tree? And this is a great graphical representation of shooting around that point, right? To be able to capture the data that's down here under the tree canopy is what we're going for, to be able to get your classified and non-classified ground points, right? So some software, you'd be able to just strip that right off and create your TIN and your topo from there. But this is what people are talking about as they refer to LiDAR returns. So certainly begs a question about accuracy and precision, right? So some good graphics here talking about this, right? Where absolute accuracy is not relative accuracy, right? So, and I think a lot of you probably understand that as technologists and data scientists out here, where we do see absolute and relative accuracy married here. Again, this is speaking about precision, but you know, that's kind of, you know, meaning, you know, being something can be accurate, high accuracy, low precision, right? So to be able to rectify your highly accurate relative accuracy and then be able to correlate that to a real place on Earth geodetically, this is what we're looking for, right? Some other representations of this. So we are looking for high accuracy, high precision, not just high relative accuracy, but high absolute accuracy.
Yeah, can you just go back to that slide there, Tom?
Absolutely.
So yeah, I mean, what I'm finding, in the two softwares that I've been using there, the Photogrammetry module and the UAS master, they're going to perform a relative adjustment first, just to stitch all those photos together accurately. That doesn't mean that you're going to be tied to, the datum that you're reporting that information in very well. So, I have an RTK drone out there. When I don't use targets, I've found photos, some of the points that I've extracted to be up to a foot off of where they should be on the state plane coordinate system. So even though that everything is relatively accurate to itself, it's not in the right geospatial position. So when you have the high accuracy, high precision, we're usually getting that through ground targets and additional check shots. And that's the absolute adjustment phase of the processing.
So talking about this, right? So we have I've got several slices here through point cloud that we did. It's a check shot across 3 different, so you could understand kind of what we're talking about here in the context of a LiDAR profile. So I have the DJI L2, which at the core, again, I've got this broken up by the sensor, I guess the guts of the sensor is a live ox, and then what type of LiDAR it is. In case you were not aware, there are mechanical LiDAR, there are frame LiDAR, there are solid state LiDAR. There's a couple of different ones, but typically what we're dealing with here, I think a lot of them are going to be mechanical, the ones that you're going to see, but again, the L2 is a frame based. So when you look through this, you can actually see the point cloud, as I say, basically broken up, and how thick this is, as opposed to here on a TV 660, much more aligned here as far as the scatter on this. Going back. Way more points here on this because I expect this was with the Penta, the 5 returns. And then finally, the LiDAR from the Wingtra, which is 3 returns. So just to give you a sense of, 3 different versions of LiDAR in 3 different budgets as well. So the the L2, you're in the, $12,000 range. The TrueView 660, this is upwards of $175,000 LiDAR sensor, and then the Wingtra LiDAR sensors in the $70,000, $75K range. So to give you a sense of here's C, B, A again, kind of go back through and look at those.
Yeah, so this is a good breaking point to try to look at our the sample data that we collected, especially since he's looking at those LiDAR slices. So the purpose of what we wanted to do was compare a LiDAR sensor to a photogrammetric sensor in some different environments. So what we did is map this forested area here, about a 14-acre parcel. As you can see, it's heavily wooded, about half deciduous, half conifer. We did do this during a leaf-off situation. We both flew at 150 feet above the ground. I was trying to get as much point density as I could from my photogrammetric sensor. So I had a 61 megapixel camera with a 55 millimeter lens. So more resolution than you would typically use on a project like this. But again, the purpose was to compare the LiDAR to what we could extract from the photos here. I was flying at 22 miles an hour, collecting an image every 0.6 seconds. So that worked out to be about every 20 feet. It took me 12 minutes to map this 14 acres here. Tom was flying his LiDAR. He had an L2 sensor on the DJI. It took him, he was flying at about half that speed. So although, you know, I spent half of the much time in the field, it took me, I had 1,100 images. It took like 18 hours to process that with my computer. Again, very high resolution type of data set, but Tom was able, you know, he did his stuff in the cloud and he processed his data in less than 3 hours. So there was a huge difference there. At the end, so let me just turn on some of these data sets. Again, this is the area here. So my information is in blue from the photo sensor and his information is in red with the LiDAR. Just gonna take the background image off here so you can kind of see. So I have, you know, I think I got some pretty good coverage over most of this area, enough to make an accurate map, but I do have some holes in here where the trees were very thick, but I have his data set in red underneath there and you can see the LiDAR picked that up pretty well. I mean, he's got some gaps in here, but not nearly like I do. Just to give you some idea of the scale, you know, the biggest gap that I might have here is about 50 feet. This is a very hilly terrain, but like I said, we still could have made a pretty good map just with that sensor here. So that's more of a kind of a rural landscape type of application. I also wanted to show more of what you might term as a hardscape here. So this is more of this actually has some features on it. This is more of my home area here, and I wanted to first just look at the detail here from the LiDAR scan. So this is akin to what we might collect on the ground as far as a detail. When I look at the same thing from the photo, so this was, you know, from the photo sensor here, I'm missing a lot of these vertical walls, and it does some weird things on the edges here. Tom's going to talk about some different software that you can use to fix that. But one thing I also noticed during this is that, you know, it's almost akin to PPK versus RTK. When you're out there collecting the photogrammetry, you really don't know what you're going to get until you process it. Whereas with the LiDAR, Tom's able to see on the controller as he's collecting these points. He's looking at the return and the intensity. He knows whether he got the points he needs when he left the field. So there was a big difference there. Lastly, I just want to look at a particular area right here at the corner of my home where you can, again, we were both flying at 90 degrees, so a nadir angle, but I struggled with the sidewalls here. Tom did not. Let me just look at a particular view here. So this is the top-down view. I'm going to turn on both data sets here. So this is basically the corner of my house right here. So Tom's LiDAR, you know, even though he didn't fly obliquely, picked up this corner very well. I could extract this point pretty easily using the tools at my disposal here in TBC. This is the photogrammetry. So I don't even have a hard edge here that I could extract. And not only that, on this vertical surface, we have just about 7/10 of difference from the true value there. So looking at the whole data set here, they basically marry up pretty well on all these flat surfaces here. The two are very comparable, but once you get into a high level of detail, you look at some of these sidewalls here, that's where a lot of the difference comes in. All right, that was all I wanted to show here. I'll give it controls back to Tom.
So talking about the digital twin. So here he's talking about kind of oblique photogrammetry. DJI Modify, again, this is just one. There are plenty of other softwares that can then go in and actually change or tweak what you've captured out there. So you see this first image here. This is a bridge, and obviously we can see some ghosting here with the traffic that's obviously on that bridge. Through something like Modify, you're able to actually remove them completely from the image, and see up here in the upper lane that is not being marked for asphalt degradation here. So in this, you see the entire lane without the cars over it. So that's pretty sweet. Now, this is something else it can do, is repairing side images or buildings, things of that nature. So tremendous, right? This is kind of leading into oblique photogrammetry. So being able to capture 3D data for facades and curbs, open trenches, something like that, digital twins, and being able to model the 3D world in true form is something that all of this hardware is able to do, and do very well. So being able to, take this information and throw it into some kind of building information modeling, some kind of basically Revit, essentially, or something like that, to be able to take measurements, to do comfort analysis, all kinds of things that can be done afterwards with the model itself. I mean, this is photorealistic, the renderings on some of these panos, as we get into some of the other technology that supplements the drone. So what if you need to get in a little bit closer, right? So slam scanning is kind of a hot thing right now. Beyond something like the SX12, being able to get in and mobily map this object or this building to create a point cloud that is not just interior but exterior as well, assuming that you have something that's capable of this. And this just happens to be something that I have here. There are plenty of slam scanning applications. This XGrid, it's amazing for 15K. What it can do, it's really remarkable. If you're curious about this, let's set up a demo. This thing's amazing. But to be able to do the panos, like this is a pano using Gaussian splatting. That's a fun Google term, looking up Gaussian splatting. Being able to essentially take a limited amount of information from a photograph and to recreate it using complex math. That is very high level of what that is, but this software and software like PointCab have the ability to do that. There's some very exciting things happening in this space right now. So talking about the overall mission planning and kind of the flying and planning portion of this, we have 3 different options to look at here. So talking about this same project, this is an area out in St. Louis that we flew, but just wanted to go back and forth bouncing between these 3. So like, if you don't have a Mavic, let's say you're finding yourself without a drone, like this is 3 stack ups. Like, so I'm going to bounce back and forth between these 3 slides here. We have the Mavic 3 Enterprise flying the same 1,167 acres. So I want to take time to notice the different time in the flight time, right? So this wound up being, 2 hours and 53 minutes to create this, and 9,000 pictures at 2 centimeters per pixel. Again, that's not bad. 2 centimeters is okay. That's fine. 9,000 pictures. That's pretty good. That's a lot of pictures. That's just the flight time. Processing that mission, guarantee that was over 3 hours. The M350 with P1 with a 24 millimeter lens, right? So not 55 like Harry's had there, or 35 like is typical. The P1 on the M350, that same site in, again, going back here, 2 hour 53 on the Mavic, hour 54 on 3 sets of batteries as opposed to about 5 with the Mavic, at the same 2 centimeters GSD for about half of the photographs. And now the RGB61 for the same 2 centimeters GSD At 400 feet, we were able to do that to get 2 centimeters and 3,000 pictures in an hour and 46 minutes for this stuff. So again, I said this way back at the top, if you're mapping large projects, and it's a 1,100 acre site, certainly it's going to lend itself well to the Wingtra. However, you know, there's nothing wrong with, you know, doing a 1,000 acre site, you know, in chunks and creating that into different, you know, mapping software and biting it up and then marrying it back up in your processing software. But just to give you a sense of 3 pretty common drones that are out there in the marketplace, stacked up between small quad, mid-size, full-size quad, and then a fixed wing option as well. So once you're actually out there in the field and you've set up, what do you do, right? So I have this air control app. So this is Aloft Air Control, the FAA's app. If you don't already have something, I couldn't recommend this more. But here's some screenshots off of the actual app that's on the phone. So again, this is just great to know where you are for situational awareness. It gives you your ceilings, it gives you any NOTAMs, you know, any temporary flight restrictions, looking through where you are in real time so that you are flying with the most up-to-date information you have. And I can attest that this is accurate. This is very accurate. I have checked this the night before going out to a project. I was flying downstate in the Poughkeepsie area, and there was a NOTAM for the president coming up there. This was a couple of years ago, going back up, and I was good to go to fly where I was originally planning, and we had to augment day of because there was a presidential NOTAM shut down and the airspace was locked down. So this is excellent. If you don't have it on your phone and you are flying drones right now, and you have not heard of this for some odd reason, I could not recommend it more. And then you're all systems go. Maybe some of you on the call that actually witnessed that in real time. You know who you are. Part 107, all right, so another hurdle, another navigating challenges, right? Getting your Part 107. This is, it's a lot scarier than it seems. It's not actually as difficult as it. For some reason, there's trepidation when I talk to people across all kinds of different places. This is not a difficult test to master, especially for those of you that are doing complex geospatial data collection and surveying. There are several excellent sources to go for help. UAV Coach is excellent. Drone Coach is great. The ASA supplemental is excellent. You can get that on Amazon. But once you get your Part 107 knocked out, then you're good to go, right? Crew management, situational awareness, that's on you. What is noteworthy on this slide, the Part 108 that I was alluding to earlier deals specifically with beyond visual line of sight. So this BV loss, FAA right here, they're trying to standardize flying beyond the horizon, right? They want to make sure that we can fly with, you know, beyond the I guess the capabilities of our eyes, right? So, you know, flying a Mavic 3, you have real-time link on it. You can see where you are. You can see the map. You can see, you know, outside your left, your right. There's even cameras on board the thing, so you can see what's going on in real time. So being able to figure this out and unlock the true potential for all this technology is extremely challenging. You do have the ability to go after a waiver here. This is very important. So you can get a waiver. You can get a provisional waiver from the FAA to do your testing so that you can apply for full approval. So that's very important to note, right? So as you get drones and you want to apply for a beyond visual line of sight waiver that authorizes you to fly beyond line of sight, you can get a provisional. So this is something else we can help you with, navigating through that. Please leverage our expertise in this regard. But we are trying to, you know, stay abreast of this ever-changing landscape of regulations, and 108 is going to be at the heart of this as soon as it comes out. But they're trying to figure out the minimum standard for the drones and their flight attitude, all kinds of things. If you're not into this and understanding what this is and what it entails, being able to basically do drone crash, like what's the drone going to do if it hits something? You know, there's all kinds of things that go into authorizing the waiver, and then figuring out a way to deconflict flight routes, right? You got airplanes, you got small aircraft, you've got passenger jets, right? You've got all this stuff going on in the national airspace. How do we deconflict that with drones so that you can get your Amazon cart, or you can get a DoorDash, drop off, right? Again, like I'm not doing that, but some people are in urban settings. And how do we figure that out? How do we move forward, right? So these are, once this does come out, Part 108 was supposed to come out last year at the end of the year. It's a little bit delayed. Certainly with the changing of the administration, you would expect that as things come in and are reset, but hopefully, now we're going to be able to see that as, things seem to be, kind of at least changing one way or the other. So deliverables, talking about the deliverables, right? So if you're not familiar with the ASPRS, they are the folks that are the experts of all things geospatial, right? So you can get certifications in technologists and LiDAR technologists and certified photogrammetrists. If you have never checked out their website, I would encourage you to go and look at it. It's really, it's great. It's not a bad place to go for professional development. But as far as, what the deliverables are, what are the standards you have, all of these are kind of part of a broader discussion of what are you doing with the data? Once you get it, you have it, you've captured it, you got it. How are you monetizing it? What are you doing with this? How are you leveraging this for your customers to provide better insights into them and downstream for their, if it's a building operator, how are you improving the lifespan of a building? How are you, cutting costs? How are you doing comfort studies or, LE lead studies, right? These are all things you can do with drones nowadays. This is an ortho I did with an oblique camera. I won't tell you what it is for operational considerations, but it was a very large site. And so orthos, deliverables of this regard, this is kind of what we're after. Volumetric stockpile analysis, right? Being able to look at mine working faces and understand and identify areas where there are potential, rock falls and danger hazard areas for your personnel. Getting into that, and then wanted to talk about dollars, right? Talk about being able to acquire this, right? There are several different options. You purchase something, do you rent it? Talking about rentals, we have customer assisted rental experience projects, right? So I actually put some numbers in this for you all to get some idea of what some of the budgets look like for this, right? For a Sky Scout, for a Whisper, for an M350. These are some of the drones and hardware payloads that we have been talking about today to actually see what they cost so you can get an idea, versus purchasing a package, or maybe you're not ready. Maybe you need to figure it out. Maybe we need to do a project for you, and we have a model for that, where we essentially teach you how to fish and run it side by side, with your hands in the controllers, and are basically your guide for it for a day. And once you get comfortable, the goal obviously is to put it in your hands, but we do have several different avenues to explore. To be able to get you gear in your hands and feel comfortable doing it, and to be able to deliver excellent deliverables to your customers. So that is about an hour here. Want to open it up for any Q&A that we have. Harry, for anybody here that's still on the call, Harry, you had some questions that you wanted to talk about, and we've covered a bunch of information here. Any amnesty, comments, questions, things that you'd like us to discuss and talk about? I wanted to leave a few minutes here to do that.
Yeah, don't see any other questions. So thank you everyone for joining us. I hope this has been beneficial to you all. And if you do think of anything or you want to follow up, our contact information is below there. And we thank you all for joining, taking some time out of your day here. Talk drones.
So much, everybody. You take it easy. Be safe out there.